Ladies and gentlemen, greetings of the day. My name is Zhang. It is my pleasure to share my research work here. Today, I am going to give a brief introduction about energy photonics. I mainly focus on artificial intelligent photonic chips development with multifunctional devices. It is known that one of the most important energy devices in modern society is supercapacitor. Energy harvesting and conservation are essential for all kinds of power sources, particularly renewable energy sources, given their global distribution. Usually, batteries are employed to mitigate the imbalance between abundant renewable energy generation and inefficient energy transmission. However, batteries suffer from a drawback in terms of low power density. In recent years, supercapacitor devices have gained significant traction in energy systems due to their enormous power density, competing favorably with conventional energy storage solutions. First of all, the motivation is mentioned about the artificial intelligent photonic chips developed with multifunctional devices. Then the research project will be discussed about supercapacitor involved with laser etching and titanium carbide DTL, 2D materials. Finally, the outlook of improvement for device performance with new proposal is displayed. Photonic chips are becoming more and more important in recent years. In order to establish a complete theoretical model of intelligent photonic devices and the principle of multidimensional multiplexing, intelligent photonic devices, and develop intelligent photonic devices for artificial intelligence nano-optical chips. Meanwhile, by establishing a theoretical model and multi-dimensional multiplexing principle for intelligent photonic devices, we can achieve intelligent photonic device units with long-range plasticity, low energy consumption, and biomimetic perception functions, and achieve three-dimensional interconnection of device units, ultimately constructing optical chips with real-time information processing capabilities by integrating supercapacitor. Solar energy is a green and sustainable energy source, characterized by periodic or fluctuating power supply, depending on environmental and climatic conditions, which can be integrated with photonic chips. Currently, batteries are commonly used to store the significant amount of electric power generated from solar photovoltaic cells. However, the limited lifespan of batteries, due to the fluctuating power supply and intermittent power consumption, can damage the capacitance of the energy storage system. Therefore, alternative energy storage technologies are being sought to extend the charging and discharging cycle times in these systems, including supercapacitors, compressed air energy storage, flywheels, pumped hydro, and others. Supercapacitors, in particular, show promise as a means to balance the demand for power and the fluctuations in charging within solar energy systems. Memristor can also integrate it with photonic chips to develop intelligent devices that simulate human perception functions using the optical memory effect of materials, develop high-speed and high-precision optical diffraction neural networks, and achieve machine learning without power consumption. The optical signal could be manipulated into photonic chips. That such research mainly focuses on using the orbital angular momentum dimension of light as the information carrier for holographic processes, and utilizing the high-dimensional characteristics of orbital angular momentum to enhance the bandwidth of holographic processes. Provide source technology for designing high-capacity artificial intelligence optical chips. Finally, all the devices can be integrated in order to conduct scientific and technological research related to artificial intelligence, and based on research on orbital angular momentum, multi-dimensional multiplexing, etc., establishes a complete theoretical model of intelligent photonic devices and the principles of multi-dimensional multiplexing, intelligent photonic devices, through research on intelligent photonic DEVI, CES. On the basis of breakthroughs in basic devices, conduct research on all optical learning, develop high-speed and high-precision optical diffraction neural networks, and achieve machine learning without power consumption. Exploring the integrated application of energy photonics research in artificial intelligence chips and other fields. To achieve the next generation of photonic neural form hardware that supports artificial intelligence, and to achieve a faster, greener, and safer future. Now, by talking about the research work on titanium carbide, it is interesting to introduce laser etching technology here to realize high-resolution structure, modify surface functional group, covalent bond content. By applying such methodology in titanium carbide modification work with laser reduction with zero-dimensional core shell structure, one-dimensional core shell structure, or even two-dimensional core shell structure, titanium carbide material could be realized for supercapacitor fabrication. It can be said that the most studied independent 2D material is graphene, which is a single-layer material that was produced by mechanical peeling in 2004. Interestingly, MXNs are also used to fabricate high-performance logic circuits and artificial synapses as active media. The low power consumption and fast switching of MXNE memory devices render them suitable for energy-saving neuromorphic computing. MXNs have great applications in many aspects, such as supercapacitor, photodetector, biosensor, field effect transistor, RAM, quantum dots, artificial synapses, memristor, CMOS. The electronic properties, topological properties, and work function, WF, of MXNs, as well as the application potential of devices, are also very important. In addition, the possibilities of utilizing MXNs for specific device applications, such as organic field effect transistors, OFETs, non-volatile memory, artificial synapses and neurons, and logic gate circuits, attracted many attentions worldwide. Finally, the problems faced by memory devices, based on MXNs, and their practical solutions, are outlined to encourage further research on NXNS. Thank